Problem number 1, procedures in estimating cement, sand, and gravel in concrete. So, estimate the quantity of cement, sand, and gravel for the concrete slab on fill of the foundation plan shown below. Using 150 mm thick Class C concrete mixture, the exterior walls and columns are 150 mm thick, and they should be excluded in computing the area of the concrete slab. So, the spaces occupied by the interiors may be neglected. So, ayan, as you can see in the foundation plan, so we have 150 mm thick Class C concrete slab. Then the thickness of the concrete hollow blocks and concrete columns are 150 mm thick also. So, for the procedures or for the procedures in method number 1, so compute the volume of the concrete member in cubic meters based from the plans and detailed drawings of the project. So it means we need to determine for the volume of the concrete slab. So I will use Excel in estimating the required volume and bags for cement, sand, and gravel. So to determine for the length of the concrete slab, so as you can see in the figure, so the total length for x-axis is equivalent to 9 meters. So if we will exclude the thickness of the wall, so it means we will subtract 150 millimeters. So ayan, so for the length of concrete slab, so equivalent to 9 meters minus, so minus the thickness of the wall, since it's center to center spacing, minus 2 times 0.15. Ayan. So, here is the new length of the concrete slab. So, units. Ayan. Then next, for the width of the slab. So, width of the slab at y-axis is equivalent to 4 plus 4. So, it means width of concrete slab is equivalent to 8 minus, so minus the thickness of the wall for the top and lower part, so minus 2 times 0.15 meters, so equals, then here is the new width of the concrete slab in meters. Then so for the total volume of concrete, so volume of concrete slab, so simply length times width, uh, length times width times the thickness. So the thickness is 150 millimeters times 0.15 mm. So here is the total volume of the concrete slab in cubic meters. So likewise, in estimating, so we are required, or it's the discretion of the engineer if he would allot for the allowance wastage. Uh, so for the allowance wastage, so plus 10%, so it depends on you, 10% allowance for wastage. So for the allowance for wastage, so simply multiply the volume by 10%. So total volume times 0.1. So here is the allowance for wastage. So the total volume would be of concrete slab would be the sum of the volume of concrete slab plus the allowance for wastage. Ayan. So equivalent to 11.05335 cubic meters. Then next, so after determining the total volume of the concrete slab, so let's go backward to the method or the procedures. Add to the above computed volume of the concrete for the allowance for wastage as discussed earlier to get the estimated total concrete volume. So we're done with here. Then next, ascertain the class or concrete mixture used for each concrete part being estimated. This information can be found in the project specification or indicated in the drawing working plans. So based from the problem, so we will use type C concrete mixture. So these are the factors that we will use in the problem. So going back, so for class C concrete, so the total volume is equivalent to 11.0535 cubic meters. So for cement, sand, and gravel, so the factors for class C concrete is equivalent to 5.49. So ito is factors. So factors 5.49. Then for the sand, 0.44. Then for the gravel is 0.89. Ayan. Then the total volume of concrete slab is 11.05335. So copy lang natin siya. Ayan. So 11.05335. 0.05335. Then to determine for the number of bags in cement, for cement, so we will multiply the total volume of concrete slab to the factors. So simply 11.05335 times 5.39. So 5.39. So here is the number of bags for the cement. So for the unit, so unit natin dito is in bags for cement. Then for sand and gravel is equivalent to cubic meters. Then next, so 11.00535 times 0.44. So the total volume for the sand is 4.863474 cubic meters, and for gravel 11.00535 times 0.89. So in summarizing, so the total bags for the cement is 61 bags. Then for the sand, so let's say 5 cubic meters, and for the gravel is equivalent to 10 cubic meters. So that's all for estimating cement, sand, and gravel in concrete for structural components of a building. So ayan. So here is our total quantity for cement, sand, and gravel. 61 bags, 5 cubic meters, and 10 cubic meters. So that's all for problem number 1. Then next. So next. So then for example problem number 2. Estimate the quantity of cement, sand, and gravel needed for 15 pieces of the typical column and footing drawn below. So as you can see, we have a column and a footing. So this is for the elevation plan, and this is for the what do you call this, top plan. So class B concrete will be used for the columns, while for footings class A concrete mix. So going back again in Excel, so let's copy the format. Ayan, copy lang natin siya. Example problem number 2. Yan ito. So example problem number 1. So first thing we should do is to determine for the total volume of the concrete column. So concrete column muna. For the concrete column, so ito, concrete column, Palitan lang natin natin. Column. Ito, column. Ayan. Excuse. So, based on the figure, so the total length of the column is equivalent to 3 meters. So, at the top of the roof beam, plus 0.3 meters, so below finished floor line, and 0.3 meters below finished grid line. So, it means the total length of the column, total length of the column is equivalent to meters. 15 meters. Then next, so the area of the column is equivalent to 0.3 times 0.3 meters. So the volume would be 0.3 times 0.3 times the total length, which is so the total length of the column would be 15 pieces pala yun. So 3.6 meters. So for the volume of the concrete column, so area 0.3 times 0.3 times the length. So length is 3.6. So here is the volume of the concrete for a single column times the number of pieces, which is 15 pieces, times 15. So here's the total volume of the concrete. So 4.86 cubic meters. Yeah. Then next, so equals na natin siya. Then delete. Then next, so for procedure number 2, so we will allot for the allowance wastage. So allowance wastage, so volume of the concrete column times 10%. So 4.86 times 0.1. So, ayan. Then to determine for the total volume of concrete column, so 0.486 plus the total volume of the concrete columns. Ayan. Total volume of concrete column is equivalent to 5.346 cubic meters. 5.346 cubic meters. So for the allowance, so you can assume 5%, 3%, 10%, so 8%, and so on and so forth. So it is your discretion. So based from the problem, so we will use class B concrete. So class B concrete for the columns. For columns. So the factors for class B concrete, which is 1 is to 2, 0.5 is to 5, 6.49. Then for the sand, 0.44. For the gravel, 0.87. So for the number of bags for cement, so total volume must be 5.346. Then ito, 5.346. So 5.346. Yeah. So multiplying the factors to the total volume of the concrete. So the number of bags for the cement for concrete column is equivalent to 30 bags. Then for the sand, equivalent to 3 cubic meters. Then for the gravel, equivalent to 5 cubic meters. Ayan. So that's all for the concrete column. Then next is for the ano ba yun? Next is for the footings. So we will use class A concrete mix, so which has a higher strength, since the footings supports the whole entire structure. Ayan, footing. So for the footing, total volume. So kailangan natin ito copy. Concrete footing. 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 Ayan. So let's first determine the volume of the concrete footing. So for the total length of the footing, so we don't need this one. Total length of footing, we don't need this one. So volume of the concrete footing based from the figure. So the thickness is 0.35. Then the area is equivalent to 0.75 times 0.75. So it means we have also 15 pieces of isolated footing. So ayan. So volume of the concrete footing, so 0.75 times 0.75 times the thickness. So thickness of the footing is 0.35 meters and 0.35 meters. So here is the volume of the concrete footing for one piece of footing times the total number of pieces. So the total number of pieces is also 15. So times 15. So ayan. So ayan na yung total volume of footings. Then plus 10% allowance. So 2.95 times 0.1. So 0.295. Then next, the total volume of concrete footing. So 3.2483. So we've just get the sum of the volume of the concrete footing plus the 10% allowance for wastage. Then plus A. Sabi, plus A concrete for footings. So based from the factors, so the factors for class A footing, which is 1 is 2 is to 4, so 7.85 for cement, then for sand 0.42, and for gravel is 0.84. Ayan, total volume. So tama na to. This one is correct. Then factors. So let's change the factors. 7.85, then 0.42, 0.84. Ayan. So for the total number of bags for cement, so the total number of bags is 26. Then for the total volume of the sand, equivalent to 2 cubic meters, and for the total volume for the gravel is equivalent to 3 cubic meters. So yeah. So all in all, the required total number of bags for cement is equivalent to 30 plus 26, which is 56 bags. Then for the sand, so 3 plus 2, equivalent to 5 cubic meters, and plus 5 plus 3, which is 8 cubic meters for the concrete column and the concrete footing. So that's all for problem number 2. Ayan. Ayan. So problem number 1 and problem number 2. 56 bags, 5 cubic meters, and 8 cubic meters. So wait, there's something wrong at problem number 2. So this one must be 6.49. So I overlooked the nature. So 6.49. So magbabago lahat yan. So 6.49. So ito magiging 35 bags. So dito lang naman nagkamali. 35 bags. So this one must be 35 plus 26. So equivalent to 61 bags, 5 cubic meters, and 8 cubic meters. So here is the final answer or the correct answer. So ito, kindly change this from 5.49 to 6.49. So ayan, ito yan. 5.49 to 6.49. I thought it was class C concrete. So it is class B concrete mixture. So ayan. That's all. Thank you.